Okay, afternoon, ladies and gentlemen. I started the recording. Just the first few things to cover. I don't know if you guys are paying attention to the notice board or not. Practical submissions are now at 8 o'clock in the morning, no longer 9, due to the excessive amount of complaints about upload times, etc. We've moved it up an hour. Please make sure you start your practicals early enough and do not wait to the last minute to submit. If you know you have bad internet on a Friday morning, submit on a Thursday. You have a full week. I have discussed this with my colleagues in computer science as well, or computer science 1, they agree. First years have the entire week to do the practical, so please make sure you submit in time. But upload time is now 8 o'clock on Friday mornings. The semester test is next week, Thursday, so please get ready for that. I know some questions have asked Prof. Coulter in the mentor session what to study for the semester test. I'm going to go through a brief overview of what to study. What are the announcements I do need to make? Remember, there are mentor sessions for all first years. You should be able to access your mentors on Discord. Lejeune, please do your practicals. They are important, getting ready for tests as well. Semester test 1 is a theory-based semester test. I've put up 2019 and 2018's past paper now. I put up 2018 this morning. There'll be 5 to 10 marks on general knowledge. Ms. van der Westhuizen and myself are still discussing that, as that is, you can Google the answer on that one, so it's a bit of a different one. We might change that slightly. There'll be a question on recursion, how to solve a value in terms of X, Y, and Z. There'll be a question on UML diagrams given a base case or a class, draw either composition or inheritance or both. Since you now both know inheritance and composition, you can maybe ask to draw both of them. There'll be here's a section of code, provide an example of composition, provide an example of overriding, overloading, etc. So you need to know both the theory and practical aspects of the course. It's not just going to be one or the other. You need to be able to provide basic information of all aspects. What we will do is everything that will be covered in the semester test will be until this week Thursday's lecture. So whatever we cover until this week Thursday will be in the semester test. During next week's tutorials, we'll go through past papers and through recursion to get you guys ready for the test on Thursday. That's about the best we can do, I think, in terms of preparation for you guys. The test will be online like you've done last semester. We'll explain the rules and how to submit later on during the tutorials and that. But yes, any other questions or anything else you'd like to ask before we start on today's lesson of inheritance? I'm hearing silence. There will be buffer time for submissions, yes. Most likely. Okay, we'll get multiple questions. I was wondering what the output is required for the practical. We'll come back to that during the tutorial tomorrow. Phillips, we'll normally discuss practicals in the TUTS just to keep the lectures focused in terms of recording, etc. There will be buffer time for the submissions, yes. Most likely half an hour to 45-minute buffer time. Those details will be defined going forward. This week, I'm going to lock off the submission for group assignment or group allocations, and we're going to start auto allocating because we need to start organizing the group project as well. How do we know which functions to put in which classes? I'll discuss that hopefully today or tomorrow. I can't guarantee I'll get to it today, just with the time. Okay, so let's start with today's lecture. If I have time near the end, I'll come back to it, but there's two aspects of today's lecture that I might need to extend into tomorrow's lecture, or on Wednesday's lecture, just depending on how we get through it. Today we're discussing two aspects, abstract classes and extending functionality. Now, is everyone okay with the idea of inheritance that we discussed last week? Inheritance allows you to inherit or gain functionality from your parent or base class. Okay. So, any questions of inheritance? Is everyone okay with what inheritance involves? Okay, we will focus tomorrow's tutorial mainly on inheritance as well, just to get you guys comfortable with that, and we'll cover a bit of composition as we picked up some mistakes in the practical. But let's push on with today's lecture. The question on the load shedding issue, we'll come back to. Just email us proof of your load shedding, and we will then not count that practical. But ladies and gentlemen, you have a week to do the practicals, so be very careful that we won't take. You can't have load shedding every single Friday. Then you need to be prepared for it and have your practicals done and prepared by Thursday. We'll take one situation where you have a problem with load shedding, but unfortunately we do live in South Africa with load shedding is a common occurrence, so you need to have your practicals done in advance. Ladies and gentlemen, this is time management as well. Okay, but let's push on as we don't waste time. As always with a new lecture, we start with something you don't really know about. Today we're going to discuss the types of programming languages. Ladies and gentlemen, there are 3 types of programming languages. One is known as high-level languages. Any guess what a high-level language is? You should be able to pick a language from the good grief, 14 is actually listed as high level. C++ is a high-level language, yes. Okay, VB is high level. C is high level. Erlang, maybe, I don't know. Then you get assembly and machine. Assembly language is, I'll give you an example later on. It's not easy to understand. LMC, I don't know if that stands for something else. Assembly is something you'll do in computer science 3 if you're doing computer science. HTML is high level, yes. Okay, I'm getting lots of high level languages. Now, assembly language is something in between. No, HTML5 is not assembly. Assembly is near machine. As we go down, if you look at the diagram here, we have high-level languages, Fortran, C, Pascal, OO, and object-oriented languages and visual languages all are high-level. Then we have assembler, and then we have machine. The lower we go towards, okay, and correction, HTML is not a language. Mr. van der Westhuizen's just informed me to HTML is not really a language, it's a markup system. So we have assembler, which is going more towards hardware. So it's getting harder for a human to understand and easier for a computer to understand. And then we have machine language, which is zeros and ones. Okay, machine language, that is literally binary 0 and 1s. Okay, so that's machine. Assembly is in between high level and machine, so it's not a simple language to understand. It's catering more towards a machine. Object code is high level. If I have time near the end of the lecture, I will give you an example of assembly language. Machine language is zeros and ones. High level is what we use. Okay, but to show you something else, on top of this, we also have, before we started programming in computers like we do now, they used punch cards, ladies and gentlemen. These are example of punch cards. And keep in mind, which is kind of insane right now, Fortran is listed as a high-level language. This is a Fortran punch card. Okay, this entire punch card, with all these sections punched out, is to work out Z1 equals Y plus Y1. This is what this code is trying to do. Thankfully, we don't program like that anymore. Okay, here is a stack of punch cards, ladies and gentlemen. This is a stack of punch cards, or deck, sorry, the correct term would be deck. are cards, individual subroutines marked. Okay, so this is like not even this is like a quarter of a program. Okay, so thankfully we don't do this anymore, and this was still considered high level. I don't know how, but it was high level. Okay, but that's just general knowledge. There are some professors in our department that did program in this punch card approach. I'm not one of them. Thankfully, I'm one of those who learned programming as you guys know it. Make it a hell of a lot easier. Okay, so that's your general knowledge, the type of programming languages, and then what coding used to look like. Okay, purposes and outcomes today. Extending behaviors and inherited methods, abstract classes, rules for abstract, and how to work with abstract. So we're going back to the UJ program because this is a nice one. It's simple. You guys should understand it's something you're used to. Now, if we look at business management, informatics, and mathematics, look how they calculate the semester mark. Is it the same? Look at business management. Semester mark 40%, semester test 2, 40%, assignment 20%. Semester mark for informatics 25, semester test 2, 65, practicals 10, semester test 1, 40. If you look at mathematics and business management, are they the same? Are they similar? Business management and mathematics, are they similar? Yes, they're similar. Okay, so that means we can use it to our advantage by creating a base class and then adjust the functionality. So as discussed before, we have the ability to override and to make something overridable and then override it. So as you can see, we have semester mark here in the base class. Our derived class, our child classes, have semester mark calculation, indicating that they are overriding it. If a method appears twice, it means it's being overridden with inheritance. So if the base class and a derived class both have a method, it means the method is being overridden. This is how we know it's being overridden. So we create the base class for the UJ module with this functionality. And notice and keep in mind, it has to be a public overridable function. Semester test 1 plus semester test 2 times 40. Is this the end of the calculation? Will this give us a semester mark? No. Okay, looking back at both business management and mathematics, it's missing 20%. It's still missing either a class test or an assignment. So it's not finished. But the common parts are done. Okay. So we have our base class with our base functionality. Now, this is the choice of overriding. We can look at Informatics 1A. Is the calculation for semester mark at all similar to that? Is there any 40% in the semester calculation, semester mark calculation? No. Okay. So do we extend the functionality or do we completely change it? Okay. We change it. Now, if we look at the semester mark calculation for informatics, we override it, but is anything of the original still being used? The semester mark times 65, semester test 2 times 25, practicals average times 1. And ladies and gentlemen, just something to remind you of, not all of your practicals count for your semester mark. So if you've done one bad practical, it doesn't count against you. We normally take the best 8 or 9 practicals of a semester. So unlike this that takes every single practical, we will take the best 8 or 9. Mr. van der West says that, and myself will discuss that matter later and give you an exact number, so you'll know as well. So if you did badly in one practical, it doesn't count. Except in this calculation. This calculation takes all the practicals. Okay, this is known as override. We override it completely. We don't use anything of the existing base classes functionality. However, if we look at mathematics and business management, they have only one difference from the base class. They have the extra assignment 20% and class test 20%. So these two, we extend the functionality. Okay? And one way is we can override it and do exactly as we had. This is correct. Okay? And it's pretty much the same. This is the more accurate way of extending functionality. We invoke the marbase.calculate_sm. The marbase dot says get the parents functionality and add on extra. So I'm getting the parent, the base classes calculate semester mark, which is this that's highlighted. And then I'm adding on this part, the assignment times 0.2. This is known as extending functionality or extending a method. We're taking the parent class and adding on functionality. This is known as extending. The same is done. Right, let's go into the next part. So this here is just general overriding, where we take the method, we change it completely. That's overriding. Okay, but when it comes to the business management and the mathematics, we don't really want to override it completely. We want to extend it. So we invoke the marbase dot calculate semester mark, which means I take the calculation, this calculation which is done in the base class, call it, and add on the extra part. Okay, this is known as extending a method. And this only can be done within inheritance. Extending can only be done within an inheritance relationship. Everyone okay with that point? Okay. Some of you are okay, some of you I need to repeat. How can we overwrite the semester mark function when the calculations are different in informatics? Remember, if you go look at the informatics, informatics inherits the UJ module and it does its calculate semester mark. Okay. Then when it comes to mathematics and business management, they also have their own calculate semester, which is overriding. But they don't override altogether. Instead, they extend the functionality because their base calculation, semester test 1 times 40 plus semester test 2 times 40, is the same. So it's common between the two. So instead of doing it from scratch again, we are taking what is already there and extending onto it, which is the marbase dot call a method. That allows us to say, use the, they both overrides. This is overrides, and this is overrides. Okay, the only difference is whether you override and completely change or override and extend. Okay, the reason informatics 1A overrided but didn't extend is the calculation is completely different. Okay, it's no longer semester test 1 times semester test 40 and semester test 2 times 40. Marbase has its own class. No, Marbase is the UJ module. Marbase is a keyword. So when I say Marbase, I'm saying the business management's base class, its parent class, which is the UJ module. So I'm saying call the UJ modules, calculate semester mark. Call its functionality and add on this. So I'm extending the functionality. This is one benefit of inheritance. Instead of overwriting and completely starting from scratch, we can overwrite and extend the functionality. So we can add to it, or in the case of Mathematics 1A, we can override it completely and start from scratch, depending on what we need to do. So if it shares some common calculation, we can extend. Okay, that's the main thing with the extending. No, MyBase won't work with static variables. MyBase is a keyword. MyBase, what it does is calls the base class. So whatever the base class is, it is calling that. In the case of the Business Management 1A, the base class is UJ module. So it's calling UJ module.calculate semester mark. So MyBase says whatever your base class is, go and get its functionality. Okay, so MyBase calls the base class of whatever class you're working on. Okay, now let's move on. Revisiting the problem. Again, what if we didn't know? What if we had no clue how to calculate the semester mark? Ladies and gentlemen, what would we do? Would we just leave it out? Any ideas? Return 0. Is return 0 the right approach? It is an answer. Initialize to 0. We could do that. What if we said, well, I can't do it. Let me make the next one do it. Okay, this is where an abstract method comes into existence. Okay, initialized 100%. No, unfortunately, that never exists. Okay, an abstract method is something that is incomplete. It is known as a must override function. Okay, now a must override function has to be completed by a derived class, by a child class. Okay, now what is important to understand, this is where I need you guys to keep focus here, is a must override function only exists in a must inherit class, which is an abstract class. As you notice, the new keyword appears here, must inherit. A must over function can only exist in a must inherit class. This is known as an abstract class, an incomplete class. We know the class has semester mark calculation. How it's calculated, we don't really know. So when we don't know how to do it, we're saying, okay, fine, we know it has to have this method. It has to have this way of calculating something. We're not sure how it's done, except in the child class. So the child class will do the work. Okay. I don't know if this is a good example or bad example. How many of you are at varsity because your parents want you to be at varsity? Not me. Are any at varsity? Question again. So how many of you at varsity because your parents wanted you to go to university because they didn't get the chance? Some of you. Okay. So in this case, the parent didn't get the opportunity to go to university, so they're making the child do the work. Okay, some of you are here because you want to be here, but also because your parents wanted you to get a more thorough education. That's also fine. And I'm not saying nothing's wrong with it. I'm just trying to find a common way of explaining the must inherit. Okay. With an abstract class, what I'm doing is I'm saying the derived classes have to finish the work. I'm starting the name of the function, but the derived class has to finish it. So in this case, the parent class started calculate semester mark. It said the function is going to exist, but the parent didn't know how to do it. So it's saying whoever inherits this class has to finish the work. So it's kind of your parents want to go to university and decided, okay, no, I can't go, but I want to make sure my kid can have the opportunity to go. So the kid gets to finish off that option or that functionality. Does that kind of make sense? Okay. So abstract classes are incomplete classes. Okay, they are generally known as incomplete classes. And the one restriction on an abstract class is you can't make an object of the abstract class. As soon as I've made a UJ module must inherit, I can never make an object of UJ module because it's incomplete. There's a term called a concrete class. Now you'll notice a keyword here also on terms of the UML, abstract. The UJ module is abstract. Okay, keep this in mind for your UML diagrams. Is it like virtual? Yes, it is like virtual for those doing C++. It is a virtual method. It doesn't really exist yet. The child class has to finish it. Okay, the lecture finishes there, but I'm still going to continue with the discussion. Okay. Only a base, actually no. Are only base used as a base class. You can have an abstract class inheriting an abstract class, but eventually you're going to have a concrete child class. What I mean by concrete class would be like the informatics 1A is a concrete class. Okay, it inherits UJ module and completes the functionality. Okay, that will make it a concrete class, and I can make an object of UJ informatics 1A. I can't create an object of UJ module because it's an abstract class now. So abstract classes have its limitations, but they're designed to provide a base class. Let's give another example. If I was to say make an object of all animals, and you had to have a method called move and eat, can you tell me exactly how every single animal moves and eats? Okay, that'll be quite a difficult task. But if I said a lion is an animal, can you tell me how a lion moves and how a lion eats? Okay, it's a bit easier. So that's how abstract works. Abstract, we provide the base structure, the skeleton, and then the derived classes that inherit it finish off the structure. They provide the missing details. So here we provide the structure, and in the base class, the next one works. Okay, I'll demonstrate this now to you. I just want to go over these additional questions as they're quite important. Okay, can an overridable or must override method be private? Has anyone tried that before? Who wants to guess there? I'll come back to your question on inheritance again. Don't worry. Won't work. Good. Some of you have tried it. An overridable and must override have to be what? Public, public, public. Does it work with protected? Anyone tried yet? Okay, we'll try in a few minutes. Okay, must override method be overwritten in a derived class? Okay, it's a confusing question. Must a must override method be overridden in the derived class always? Actually, no. It doesn't always have to be. It just means I have more abstract classes. Okay, I'll explain that in more detail tomorrow when we get a chance. Okay, I'll explain it. What's with the exception? Okay, an abstract method requires a class to be abstract as well. True or false? So if I have an abstract method, the class must be abstract. Good. Excellent. Okay, that is true. If I have an abstract method, immediately makes the class abstract. Now, this is another question. An abstract class does an abstract class have to have an abstract method? Okay, this is where you can have an abstract class, but it doesn't have to have an abstract method. So that's actually false. Okay. With an abstract class, we can create an abstract class. Remember, what is the limitation on abstract classes? What cannot be done with an abstract class? Okay, you can't make an instance of it. Okay, we can't instantiate, we can't create an object. So if we don't want people to make objects of a specific class, we can make it abstract. Even though it's got all the functionality, we can still make it abstract. One thing, ladies and gentlemen, people have been querying me in Discord and emailing me about. I just want to deal with it now. When you're creating your class, I've seen some people maybe make the mistake of right-clicking on my project and adding. Be careful of that. It makes the class, but the problem is the class is no longer visible by default. So when you create a class, make sure you right-click on the name of the project and go add. Class, so let's go add the uj module.vb. Make sure that your class is visible like that. Okay, if I add it inside my projects by mistake, add new item. I just want to make a class. Yeah, do we see it? Okay, can we see my class anywhere here, or class.1? Okay, so be very careful of that. If your classes aren't visible, you may have made them inside of my project, which means they aren't really visible properly. So be careful of that. Make sure you're right-clicking on the name of the project and go add. Okay, so a must inherit class. That's abstract. It doesn't necessarily have to be have an abstract method. It's abstract already by just saying must inherit. So let's just give it a private st1 mark as integer. Okay, now we'll do a lot of the examples in the upcoming lectures, don't worry, but I just need you guys to understand the idea of the abstract right now, then we'll focus on extending as well. So my base class, so we put my base to derived classes which have the same calculation. Yeah, correct, Sergio, in terms of the question. But with abstract, I was going to show you something with it. Let's see if we can do a protected abstract. It's a protected works as well. Okay, cool. That's something to know. But we're going with public. Notice something, ladies and gentlemen. Is it giving me any errors? Where's the end function? Is there an end function? Okay. Don't see it? No. Nope. Will protected be visible inside the form? No. Protected will not be visible inside the form, only in the inheritance structure. And ladies and gentlemen, with an abstract method, we do not have an end function. You're correct that you don't see it. We don't need it. An abstract method is just one line. Done. That's how we know it's abstract. Remember, an abstract is basically saying, I don't know how to do it, so I'm going to make someone else do it. Okay. A must override function is basically saying, I don't know how to do it now, but the next one might be able to do it. So if let's go and do, it's being incomplete. Yes, it is incomplete. That's the point of it. We don't know how to complete it. So let's go and make another class so you can see what happens. Class. Now you cannot be abstract students in exams. You have to complete your damn things. How do we must override again? I'll get to the must override now. So let's go and make this the informatics. Okay. Now, I've declared this as must override. Everyone okay with that? That's it. Now, notice something when I do this. Okay, inherits, UJ module, press enter. It automatically completes the function and throws a incomplete exception. We'll be discussing what that means later on. But you notice it automatically goes and adds a function to the class. Basically saying, cool, I didn't do it, you need to do it now. So this is how a class is then completed. Or the function is then completed by us making the child class do the work. The derived class is essentially forced to complete the functionality to a degree. Why I keep saying that is because you can do this as well. You can create a child class as a must override as well, and then basically gets pushed down the chain of problems. So the child class eventually has to do it. Okay, but we're not going to go there today. Today we're just dealing with basic abstract and overriding. Make the child do all the work. Nice. Oh, that's the terms in IT. Function name giving an error. I think it was to do with something else. I'll come back to that error later. Okay, so is everyone okay with what abstract, the principal idea of what abstract is? We're going to touch on it more tomorrow in the tutorials and hopefully in the lecture on Wednesday. But the basic idea, do you guys understand? Okay. Because we've got 5 minutes left of the lecture, so I want to get the basic understanding out of the way, and then we can always expand further on Wednesday or tomorrow, depending on how things go. Partially is even fine. Okay. Because remember, what we discussed today is, again, new information, ladies and gentlemen. You notice that there's constantly a flood of new information. Unfortunately, as Informatics 1B, there's a lot of concepts to cover. So we're going to constantly be covering new work. So we looked at how to extend functionality. Extending functionality is invoking the mybase command. Okay, so we go mybase, and that allows us to extend the functionality. Then we looked at abstract. Abstract is when we have incomplete functionality. Pretty much. The question in chat is, so most functions in IT are inspired by real life events. Generally, they are, or real life concepts from engineering and in other fields. Remember, IT is a new profession and a new industry. So it's not as old as like your engineers and etc. So in this course, technically it's software engineering, although the engineers don't like us calling it that. You're learning, we learn principles from engineering, we learn principles from all over the place and combine it. So the idea behind abstract is when we don't really know how to finish off a simple problem or finish off a situation, instead of forcing it to be resolved there, we almost push it on to the next section where it's more understandable. Remember, objects are a very high level way of programming, and sometimes we don't know how to solve the problem in a certain class, but doesn't mean it's not solvable. It might mean we have to push it to the next class to be solvable. Like I spoke about the animals, and then I spoke about a lion. I can't explain how all animals move, but I know animals move. But a lion, I can explain how it moves, because a lion is a specific type of animal. That's inheritance. All animals can move, all animals can eat. But how they do it specifically depends on the individual animal. So we make it a function in the base class that is must override, and in the child class, the lion, we then provide the complete functionality. Okay, does that make sense? I see the question in chat. I'm not sure about Admiral Grace Hopper and Grace Murray Hopper. I'll have to look at that. There might be different people. Admiral is the title. Okay, the same person, confirmed by both. So her full name is Admiral Grace Murray Hopper. Long name. So can we call the overrides function on other functions for calculations? Yes, you can, but the base class must be a overridable. Overrides can't be called on any function, only functions that are overridable. So you'll notice that the base class, the UJ module, is an overridable function, which means the child class has the ability to override it. It's not that it can override it by default, it's we giving the permission to be override or overridden. So it must be an overridable in the base class. An overridable function is normally visible because it's public, yes. So the form can see it because it is public. But doesn't mean the form can go and override it. Remember, overriding only exists inside inheritance. Only with an inheritance relationship can things be modified through overriding and the must overridable and the overrides. Okay. I know I covered 2 brand new topics today, but again, we'll break it up more in tomorrow's tutorial or on Wednesday, depending on how time goes. Because tomorrow we still have to do a base tutorial on inheritance, so we might expand on it on Wednesday, just how time is managed. Okay, that's today's lecture done. I'm looking at the time as well. Any last minute questions before I stop the recording? Remember, ladies and gentlemen, we do appreciate the students that do come online for the lectures, as you might ask questions the other students don't have a chance to. But remember, those who are watching the video, you can ask questions on Discord in the lecture channel or the lecture question channel, or you can put it on YouTube. I check the comments as well. Okay, we've got a question. How do we access overridable functions in the form? Same way as you access any other function, the name of the object dot the method. I asked inheritance, sir. I know there was a question earlier. So when other classes inherit from a parent class, the functions you write will also be inherited. Yes, functions are inherited as long as they're public. Anything that is public is inherited or protected. The function name error I'll deal with the next lecture. Okay, that is a joke. Sarcasm. Will protected be visible from the form? No, protected is not visible in the form. Protected is only visible inside the classes. So we put MyBase to derived classes which have the same calculation and extend the functionality. Yes. The MyBase is allowing for extension in the derived classes. So the child class can extend the base class function or parent class functionality. You got to, unfortunately, the terminology. I'm going to swap between parent and base and child and derived. But remember, parent and base class are the same thing. A child and derived is the same thing. It's just a different terminology to use to represent them. Okay, I think that's all the questions, unless I missed something. What is an interface class? Help. Why do you guys... interface class, we're still going to discuss. I'll most likely will discuss it this week. So interface class is super abstract. That's the easiest way to explain it right now based on what you know. Interface classes are completely unimplemented classes. I don't really call them a class. They're known as an interface. It's a different type of inheritance. We will discuss it most likely Thursday. That'll probably be the last thing I'll discuss with you guys. Okay, one thing just to let you guys know, I think it's week 6 now. Mr. Van Esdeisen and me agreed that we each would give half the semester of lecturing. So I think next week Mr. Van Esdeisen starts the lecturing process and I get to sit in the background throwing in the random comments. So this is probably my last week of lecturing for you guys, and I finally can sit and cause cuck in the background with a chat. So yeah, that's it for today's lecture, ladies and gentlemen. Again, keep in mind, this is week 6, ladies and gentlemen. The semester is disappearing. Language. What do you mean language? For 5 marks, can you please explain abstract classes? Why abstract classes are necessary? For 5 marks, out of what? How many marks is it out of? Abstract classes are necessary because we don't always know everything. An abstract class exists because we know we have a base class. We know it has some functionality, but we don't know what it is yet. And we need to build on it. So abstract classes allow us to work on a very obscure idea and build on it as we go along. Okay, abstract classes are actually very useful. Unfortunately, you don't see the full extent to an abstract class in first year. It comes out more in your third year and in honors, where abstract classes truly show their full potential. When Mr. Van Esdeisen teaches you polymorphism, that also shows the true potential of abstract classes. as they are hell useful, more useful than you realize right now. But they allow us to define functionality that we don't know how it works just yet. So our full knowledge for Practical Civil is abstract, pretty much. Your full knowledge for Practical 6 is abstract to a point. We've covered the ideas. We will finish off the ideas before Prac 6 is due. Do not worry. You still have plenty of time, but you can start working on Practical 6. Nonetheless, you can build up the functionality and find which methods are abstract. Are they abstract, or are they extendable methods? This is what you've got to determine as well. As what needs to be displayed for Practical 6, we will define that in a notice, or we'll update Practical 6 and make a notice that we've updated it. Going back to one of the earlier questions. Okay, but that's it for ladies and gentlemen. I'm going to stop the recording.